Okay, so this will be practical task for number 6 and delivered by Jason Harman from 12 Leopold. Okay, so let's just directly start with reading the questions. The probability, yeah, that Anthony buys an item online in any week is 0.35. Anthony does not buy more than one item, yeah. I mean, each week the maximum amount of Anthony buying an item is only one, not greater than one. Okay, so for point A, find the probability that in a 10-week period, so this is the span of time, Anthony buys at most 6 items online, or equivalent to, well, 0, 1, 2, 3, 4, 5, and 6, right? Okay, so let's do the A. And for doing this, we will be using binomial distribution, yeah, with the general forms of, well, nck, yeah, you times it by p to the power of k and 1 minus p to the power of n minus k, where in this case n will be the number of trial, yeah, number of trial or span of time, yeah, which is 10 weeks for this case, and k will be the number of, like, the successful or the desired event to occur, in which in this will be the Anthony buying an item and at most 6 items online. Ideally, in this case, k must be from 0, yeah, so here 0 until 6, because it cannot be greater than 6, right? It cannot be greater than 6, or it cannot be 7. Nah, and so it'll be long, right? Because how many elements shall we calculate later? 0, 1, 2, 3, 4, 5, and 6, 7 elements. And to shorten things out, we just use the complement of the probability. That means we find actually the value of Anthony buying from 7 until 10. That means the K in here, yeah, so that it will make the progress faster, from 7, 8, 9, and 10. Yeah, 4 elements compared to 6 elements. Now, where P, yeah, P, let me change the color, where P will be the successful event, right, or Anthony buying. So we just make it PB, P by 0.35, with the P not buying, yeah, yeah, just the rule of probability, everything must be equal to 1, yeah, when they are added. So this must be 0.65. Okay, now that we have got all of the information and the forms, we just use the, well, input everything to the binomial distribution. So for P, of 7, yeah, the first P of 7 actually will be 10C7 to the power of the successful attempt, yeah, in which buying is 0.35 to the power of 7, and you make the not buying probability 0.65 to the power of n minus k, which is 3. And this, yeah, when you calculate, it'll be 0.0212. Sorry. And P8, yeah, so we calculate actually one by one, and it'll be just the same, like exactly the same, yeah, just the power difference. Okay, 8 and 0.65 to the power of 2. And when you calculate, it'll be 4.2814 times 10 to the power of negative 3. And the P9, yeah, it'll be the same to, yeah, and even like when we use the complement, it is still wrong, right? I mean, long, right? And just imagine how long it'll be with the ideal one, 6 elements. Well, this will be 5.1 to 30 times 10 to the power of negative 4. And the last one, yeah, 10C10, yeah, which is actually 1, so we can just cancel it out because, I mean, it doesn't affect any value. And 0.35, 10, 0.65, 10 minus 10 is what? 0, right? I mean 1 to it does not affect the value. So 2.7585 times 10 to the power of negative. Sorry, times 10 to the power of negative 5. Now, now to find the whole probability, we can just add all of them, right? To find the all of the probability that Anthony buying more than 7 items, yeah, how much, right? And when you calculate the P total, yeah, for this one, it'll be 0.0260. And this one is actually approximation, yeah, because all of the numbers is actually like this one, like power to the 7, right? And decimals, it is actually irrational. And this is only approximation with I use 4 decimal, yeah, in place. Okay, now because as I said mentioned before that we use the complement, that means the probability of this thing happening is 1 minus this probability, right? Because there are two events, right? Buying more than or equal to 7 or buying less than or equal to 6. I mean, we just minus this 4. Oops, this looks like 6. 4.0260, and you will get the value to be 0.9740, or yeah, approximation. If you want to make it shorter, 0.97. And this is the answer for part A. Now, we're moving on with part B. A lot simpler actually, because yeah, it's shorter. The probability that Anthony buys at least one item here is the clue. At least one item online in a period of X week is greater than 0.99. Find the smallest possible value of X. So we are finding the X, which is the period. So in what span of time, yeah, Anthony will have a chance of buying more than one item of 0.99. We find it. Okay. Again, yeah, let me just give a line and for part B. As I've mentioned, ideally, we still use the same formula, yeah, the binomial distribution, right? And because it is more than one, the k, yeah, the k will be 1 until 10, which is, well, it's just too much, right? And so we took the complement again, yeah. So how many, yeah, the k? Only one, even, because it shall be greater than 1. I mean, the complement is exactly 0. So the probability of Anthony not buying anything, we are calculating that. And because it is given that in the question, the probability of Anthony buying more than one item, yeah, in a span of period X week is greater than 0.99, that means the probability of Anthony not buying anything or k equals 0 shall be P, yeah, P accent, P less than 0.01. Why it should be less than? As I mentioned that the law of probability is, well, P plus P accent must be equal to 1. And if both are greater than, well, it have a chance of making it more than 1, which, well, violates the law of probability and it cannot be used, yeah. Or you can use your logic too, right? If this must be greater than 0.99, then the other, yeah, the complementary must be less than 0.01. Okay, so the n here will be x. Still use the exact same form, nck, that means x, right? C, oops, yeah, it's okay, I use red, xck, which is 0, and turns out this is a lucky form, because everything, yeah, combination of 0 is 1, and we times it by the complementary 0.35 to the power of 0, and then 0.65 to the power of x. It's just the same, right? And this value, yeah, this combination and this form must be equal to the value of this, to the accent one, to the complementary one, which is less than 0.01. And because this is 1, this is 1, yeah, to the power of 0 is 1, and combination with 0 is 1. And that means we can just use some basic logarithmic with the basis, yeah, of 0.65, right, to find the value of x, the inverse of exponent. And this will be log, yeah, log 0.65, 0.65, yeah, with the value of 0.01, yeah, must be less than, must be less than x, right? Some basic concept of logarithm. And because we cannot calculate this, it's impossible, so we'll be using the help of our dearest Casio. Let us calculate this. Okay, and the value is 10.69. This must be less than x. And because we are speaking about base, it should be a round number, not a fraction, not a decimal, not the irrational one. And so we shall round this to be 11. Now, but what does this value reflects? Well, that means like the probability of Anthony, yeah, buying like at least one item in the span of X period, yeah, must be like the bare minimum is 10.69. But because we take the round number, it shall be 11 days. So we can actually flip this like X, that means must be greater than 11. But because the bare minimum is 10.69 and we round it up to 11, so can we put the equal then? Yes, because 11 still included within the region, right? This one, like for example, if the 10.69, yeah, this is the region, and x equal to 11 is actually in here. So it's definitely still in the shaded region, and so we can use the greater or equal than 11. That means, yeah, Anthony can be right 11, 12, 13, yeah, the span of the period, yeah. So yeah, everything is included. That means the x or n, yeah, then is actually n, right, must be greater or equal than 11. And this is the answer for part B. Thank you and have a nice